Hi and welcome to Geeks for Geeks. Can I have a quick plus one in the chat if I'm visible as well as equally audible? Then we would start right away. Have a quick plus one in the chat if I'm visible as well as equally audible. Then we would start right away. Okay. Hi Vamsi. Hi. Okay. Hi. Okay, good to go. Let me check the other channel. Oh, sorry for the ads. I can't help it. Just a sec. Let me see if it is going correctly. Yeah. Okay. Manav Verma. Hi Manav. Good afternoon, Vamsi. Okay. So we would start right now. Sorry. Okay. So today we would be discussing the yesterday's problem, alien dictionary. Okay. And this problem came in Amazon, Google, and three more different good companies. Okay. So this is a very important, and the success percentage is around 49%, and it is a hard level problem. Okay. Okay. So now let us move forward. So let us start with the question. So we are given a sorted dictionary of an alien language having n words and key starting alphabets of standard dictionary. Okay. Find the order of characters in the alien language. Okay. So what it is trying to tell is, okay, it is trying to tell us it would give you a dictionary. Okay. But the dictionary, the language of the dictionary is different from the language of ours. Okay, good to go. So now, but there is one more catch in this. What is that catch? The catch is that I mean the words, okay, words or the alphabets would consist of the first key alphabets of our language. Okay, the pronunciation might be different or the words might be different, but the alphabets would be same as ours. They would use the same A B C D. Okay, and in our language, cat, okay, what I want to tell you is that in our language, cat means cat only. Okay, billy. But in their language, what it is trying to tell is it would use the same alphabets, but the words might be different, like ATC. In their language they have used the same alphabet, but in their language it might be the case that this is meant as cat itself. Okay, the alphabets would be same, but just the words meaning might be different. So what it is trying to tell is, I would be telling you with the help of an example. Okay, so there is a BAA and ABCD. Okay, what is the normal dictionary order? Dictionary order is that the smaller element would come before the greater element. That is it. Okay, what is it? If I want to find a word, meaning of a word that starts with an alphabet A, so I would start finding at the beginning of the dictionary, not at the end. At the end would tell me the words that would start with Z itself. That is it. So in their language, B comes before A. That is what it is showing. B comes before A and then A, okay, and then C is coming after. Okay, so we can see this and tell that B, A, C, this order would remain. This is true. Now the next thing is that here these two, C A is same, C A is same, B D. So we now know that B is smaller than D. Good to go. B is smaller than D. So we need to take out all the relations and we need to tell it. Okay. Now I would be again explaining you in very short. Okay. But can I have a quick plus one in the chat if you have understood this question or not? But I would again explain you because this is a quite tricky part. Okay, but till then, can I have a quick plus one in the chat that you have understood or not? If you have successfully understood, I won't be exaggerating much. If you have not understood, I would be explaining it again. Okay, so what I want to tell you is that there is a alien dictionary. There is a alien dictionary where the ordering of alphabets might be different from human. Okay, that means in normal in according in our language, a comes before a comes before b, but in that alien dictionary it might be the case that b would come before a. Okay, so in the same way, this dictionary words would be given, and we need to tell which words come first or which words come last. This is it. This is only the question. Okay, so now how would we try to solve this question itself? How would we try to solve this question? Okay, to solve this question, just take this, paste this. Okay. By the way, very much thank you, Adarsh. Very much thank you, Shivangi. Very much thank you, Ankita. Okay, very, very thank you for responding. Okay, thanks a lot. Okay, now, now we are told that we would be using the first four letters of English alphabet. Okay, what are the first four letters? The first four letters are A, B, C, D. So we need to know the ordering of the words which consist of A, B, C, D. Okay, good to go. This is till now the observation. This is given only, not an observation to be honest. Okay. Now we know that in a dictionary, if cat cat comes before dog, we know that cat comes before dog. Okay, just try to relate with the human dictionary. In a dictionary, cat would come before dog. Why? Because C is smaller than D. That is why. So we know that B is smaller than A. How much smaller? We don't know that. Why I'm telling how much smaller we don't know that? I'm telling you. It might be the case that this is a cat. Okay, okay. And this is zebra. So we know that cat is smaller than zebra. Cat would come before zebra. But there might be other words too which would come between it. We just know that cat is before zebra. We just know this only. Okay. So we know that B is smaller than A. So B is smaller than A. We know that. Now we would write all the relations. Okay. Now again, A is smaller than C. We know that A is smaller than C. Okay. Now I would take another example. Okay. So now we have I'm extremely sorry. Okay, so now suppose we have a word as A, A, D, and we have another word as A, F. So we know that this would come before this. Why this would come before this? Because this is same, and this is smaller than this. So this would come before this. We know that this is a common thing. So we know that C is same, A is same. So B is smaller than D. Okay. So we now know that B is smaller than D. Okay. Now, how can we move forward? Now, here we can again draw a conclusion that Praveen Kumar Shah, are you fine? Yeah, actually I am having a fever. Okay, that's why. Okay, so A B C. This is same as A B C. Okay, now we know that A B C D and A B C A. Okay, and D is smaller than A. Okay, so we know that D is smaller than A. Good to. Okay, now we have drawn enough conclusions. Okay, so now we would try to tell. Okay, so now A is greater than B. Okay, and A is greater than D, but A is smaller than C. So A would be greater than B. Okay, so can you tell me the series? Okay, can you tell me? I have drawn all the relations. Okay, I have drawn all the relations. Written only this line solves the problem. Ha, okay, don't do that. Don't do that, please. Okay, can you tell me the series? Can you tell me the ordering of the ABCD? Can you tell me the ordering of the alphabets? I have written all the relations. It is quite simple. Can you tell me all the relations? Can you tell me the relations? Yeah. Okay. BDAC. Yeah. BDAC. Yeah. Yeah. Absolutely. That is how you can draw the conclusion. Okay. So, but this won't work. We won't have any this thing. But we can see that we need to build up some kind of relationship between the other alphabets. Okay, why I am telling you that between other alphabets? Why? Because B is greater than A, so we can't directly write that B A. We can't write that. We can't, and that is also not happening here itself. We know that B, here comes D and then A. Okay, so we can't directly write just BA. It would not solve the purpose. That's why we need to keep check of all the relations. Okay, this is a relational operator. This is a relational operator, and we need to check all the relations. We need to check all the relations. Whenever we talk about relations in programming, we talk about one thing. What is that one thing? Can you please tell me fast? Because this class is getting interesting for now. This class is getting too much interesting now. Okay, whenever we talk about relations in programming, we talk about one thing that is known as graph. Okay, this is the first thing that should come in our mind. Okay, now we come across graphs. Now, what are the different things? It's toposort coming in picture. Yeah, toposort would come in picture, but how toposort would come in picture, that is the main part, and that is important. Yeah, I can also tell that toposort is coming to picture. Just learn toposort and it would be good to go. But we are not concerned about that. I'm trying to solve, we are all are trying to solve a questions. Okay. So I am just trying to tell you and convey you how can you direct to that conclusion that here topological sort would work. Topological sort would work. Okay, that is the main part. Good to go. Yeah, build a graph. So what we can simply do is we can relate, we can simply relate b b with a and a with c, okay, and then b with d itself. Okay, so now there is a thing known as, okay, now suppose you are not able to come up with a solution, just you know that this is a graph problem. So just whenever you know that this is a graph problem but you don't know how to solve this question, just think of all the things that you know. Okay, like, can I use bipartite, can I use DFS, can I use BFS, can I use Dijkstra, can I use flood version? Think about everything you can. Think about everything you can. Can I use 01 BFS? Can I use this? Can I use that? Can I use this? Okay. Whenever you are not able to come up with a solution on your own, try to think of things that you already know. Okay. Use that only. Okay. So now, first was the first thing. First, I would build a graph. Okay. The first thing would be done is I would build a graph. How I would build a graph? Yeah, B to A. And what I would do is then B to D. B to D. Okay, B to D. And then A to C. A to C. Good to go. Okay, there are nine viewers at the moment. Can I have a quick like at the video? Because the like counter is only 3 with my like included. So can you please just like the video? Please, if possible. Okay. So now this is it. This is how you can do this and it would be easy. So now if I do a DFS, the first and foremost easy thing that we learn in graph is DFS. So now if we do a DFS traversal, okay, if we do a DFS traversal, okay, so if we do a DFS traversal, this is just like scheduling things that we need to complete this before this, we need to complete this before this, we need to complete this before this, and whenever we there are prerequisite to a particular thing, there is a thing known as topological sort. Topological sort. Now, what is topological sort? Now, I would explain you why this topological sort can be told. Okay, suppose there is a course A. Okay, and to learn course A, I need to learn course B. Okay, and to learn course B, I need to learn course C. Okay, good to go. So now again, okay, now these are all the dependencies and we need to find a way. The graph can be very much long, but I'm not drawing it because this is out of the scope. I assume that you need to already learn topological sort and I can't teach you topological sort, DFS and all things in one video only. I would just tell you how topological sort works and how to do it. But understanding topological sort, if you want that, just comment in the video. I would ask the team of Geeks for Geeks, and if they allow we can have a class of it. But the topological sort would take a lot of time, it would take around an hour. Okay, so now if we now we need to find a way, okay, find a way where we can complete all the courses with proper dependencies, like completing B before A. Okay, completing B before A, completing C before B. Okay, these all things. Okay, now how topological sort is performed. Okay, but before moving forward, that how topological sort can be done in the most easy way. Okay, can you please just can you have a quick plus one that you have understood till this point? If you have not understood at any minute point also, I would again explain it, because it might be the case that it might seem easy for me, but it is hard for you. It might be the case. We are all not same, and we are unique in our own ways. Okay. So can you tell me where you didn't understood? I would be waiting for 1 minute. How to build a graph is the most easy part. I saw other submission and they were using some complex ideas, but I won't be using that. How to build a graph is the most easy part. Okay. Don't worry about building the graph. Thanks a lot, Adarsh. Thanks a lot, Manav. Thanks a lot, Ankita. Can I have a quick plus one from others too? The live viewers are much more. Okay. So till now you have understood. Okay. Now how to do topological sorting? Okay. We can do topological sorting by what is the how to do topological sorting? Invert the relations. Invert the relations. The first thing we need to do. The next thing we need to do is perform DFS. Okay. And then the third thing is insert insert source in whatever data structure. I would be writing container. Why? Because it might be the case that you are entering in a vector or a string, whatever be the case. In this case, we are inserting in a string, but in most of the times we are inserting in a vector, so it might be the case. So I'm generalizing it by saying that container. Okay, and then reverse the container. This is it. If you do just this thing, your topological sort would be done. This is it. This is the simplest step of topological sort. Okay. Now, how to what do you mean by invert the relations? I am making a notes for you. Okay. Just understand this, and I would tell you when to take screenshot. Take a screenshot and keep it and revise it when needed. Okay. Now, if there was a relation of A to B already in the graph and you need to perform topological sort on it, you need to convert it to A directed to B. Just invert the relation. Directed graph, it was a path from A to B, just make it inverted and make a path from B to A. Okay. Now perform DFS. What would we do? Do a DFS like the same old way. So I would be writing old way. Simple. Just visit the node, and if the neighbors are unvisited, visit it. Okay, this is it. No problem. Okay. Insert source in the container. Now, when to insert the source in the container, I would be telling you. Okay, just write DFS. Good to go. Just write DFS. This box here source, and then insert source. This is it. Here we have done a DFS of the source this, and at the end, just before the completion, we have to insert this. Okay. Now whatever answer we have got in our array or a vector or a string, we just need to reverse that, and it would tell us the topological ordering of the graph itself. Okay. Reverse mean the same. Okay. Okay, everyone please take a screenshot because this is important. Okay, everyone please take a screenshot and give me a +1. I would move forward. Okay, just take a screenshot and give me a +1. I would move forward. Then I would move forward. Okay, just take a screenshot and tell me a +1. I would move forward. Just I'm waiting for you to take screenshot. And if you want, I can just turn off my video so that you can take a proper screenshot. You don't need to take my picture. Okay. Ankita Kumari took a screenshot. Manav also took a screenshot. Others also took a screenshot. Okay. I assume that most people have took a screenshot if they need it. Okay. So I would be moving forward. Okay. We are now moving to the implementation. Because the theory is done, the pseudocode is already explained with step-by-step explanations. Now, what are all the things? Just to wrap up before the implementation, because after moving to the implementation, you won't get any time to think after the question. So now, what are the things that we have collected till now? There is a relation between alphabets. Okay, whatever be the things, alphabets. Okay, so now we need to find ordering of the alphabet. Okay, so now we need to sort that. So whenever we talk about relations, we talk about graphs, and we need to sort that. What is the thing that is available in graph? It is topological sort. How is topological sort performed? Very easy. Just invert the relation. If you have a path from A to B, just make it B to A, then perform the DFS same old way. And just after the DFS, just insert one line, that is insert the source into your answer and then reverse the thing. Okay, and it would be good to go. So now we would talk about building the graph. Okay. So now, before talking about building the graph, let me tell you how many of you are aware that A, B, C, D, E, F, all the special characters, all the words have ASCII code. Okay. Like they all have numbers associated with it. Okay. Now, I would explain you with the proper thing. Okay. And this is a very important trick that needs. Okay. Okay. I would tell you what I want to tell. Okay. First, we would write char c is equals to a. Okay. Then int x is equals to c, and then c out x. This is a very important trick that requires us. Okay. Good to go. So now the value of a won't be a. It would be different. What is the value of a? The value of a is, yeah, the value of a, okay, when you assign it to an integer, okay, is 97. Okay, and what would be the value of b? It won't be arbitrary, but it would be value of a plus 1. That would be 98. Okay, and it would be the same. It is fixed, and this is known as ASCII. Okay, this is known as ASCII. In the same way, special characters also have ASCII values. Okay, like 36. Okay, and then capital A has a different ASCII value than small. Okay, suppose the value of capital A is 65. So what do you think the value of C would be? the value of C would be 67. Okay, so we would take an advantage of this only. How can we take an advantage? Because the first K letters, now how many letters are there in the English alphabet? 26 only. So even if we have Z also, even if we have Z also, then what is the size? The size would be 122 only, which is feasible enough. So we would take advantage of this one only. Okay. Now one more thing. Okay. Now one more thing. Now char C is equals to 122. Good to go. And we can do the reverse of this. Okay. This is it. Even we can play with the same thing. Okay. If we assign the ASCII values to the character, it would behave the same way. Okay. So we would take we would take advantage of this one only. Okay. So let's suppose perform the same thing. Okay. So we would move forward. So am I clear with this or not? This ASCII value thing, this works like a charm. And why this trick is important? Like suppose you want to hash the values of A, B, C, D in constant time. You can use a vector, you can use an array. Okay. So now the thing is that one more thing. Now many people would tell me that you Siddharth, you have taken a very long and you are wasting space. But the thing is that I have wasted some space so that I can explain you better. Now the next thing what can we do is int x is equals to character character C minus character A. Okay, this can be done, and if we output x, see the value is 2. Okay, so we can do the same thing, that 0 would represent A, B would represent 1, and C would represent 2 by subtracting A to it. But I don't want to, but I want the problem to be as easy as possible. But it might be the case that, okay, so now we would move forward. Okay. By the way, if you have understood, then you can be shy and you can not ask me. Okay. But if you have not understood, then please consider asking me, because I because I would be helping you, because I don't know where you would get stuck. Okay, so it might be the case that I am not aware where you are stuck. So just let me know. So what we are doing is, okay. So now A, B, C, okay, and D, E, F. So we know that this is smaller than this. How? Because this is different. Okay, good to go. So now one more thing. Suppose A, and then D. So we know that this would come before this. How? This is same, this is same. So same won't contribute anything. Same won't give us where it would exist. Okay? So we are removing this and we know that A comes before D. So this is good too. Okay? So we would do the same thing. While the characters are same, we won't be considering it, and we would be considering the first character which is different. Okay? Just think about the normal dictionary and compare it and write it. Okay. So now what we are doing is we are comparing the consecutive two characters. This is string 1, the present string. This is string 2, the next string. Suppose this is string 1, this is string 2. Good to go. So now j is equals to 0, while j s1 is equals to sj j plus plus. So what is this thing? I would tell you. Suppose this is s1, this is s1, and suppose the string is a, B, and then C. okay, and F, W, and Q. Not F, W, and Q. Let me keep it the same thing. Okay, first letter same. A, B, and then make it this one D. Okay. So now we know that these two are same. So at first J was 0, so J was pointing at this position. When J was 1, are pointing this position, and this is same. And this while loop would work till we got a letter which is mismatch. Why it is mismatch and we know that this is not different? Because we know that C would come before D. Good to go. So now C would come before D, so we have pushed back C with D. Good to go. So now again skip this for now. Just this is the building of the graph itself. So am I clear with this or not? Just tell me. Okay. Am I clear with the building of graph or not? Okay. Am I clear with the building of graph or not? Can I have a quick plus one? Or if you have not understood, can you tell me? Okay. Swagger understood. Can everyone please tell me if the building of the graph is clear? By the way, Shivangi, did you understand? Because you are the one who were asking that how to build a graph. This one, Shivangi. Yeah, Ankita, thank you. Can everyone please reply so that the class would be lively enough? Okay. So building of the graph is clear, but everyone please try to reply. Okay, because I would know that everyone have understood or not. Okay. So now we are doing the DFS. So I am a very big fan of declaring everything in the global space so that I don't need to pass everything in the function again and again. So I'm a very big fan of declaring things in global. Okay. So I have declared a global topo which would tell me the answer. I have declared a of vector of int of array, okay, of 150. Okay, 150 I took because it max be 122, but I took it 150 for to be on the safe side, and visited array as 300. Okay, so I didn't alter anything. I took a upper bound and more than that. Okay, so at first what we are doing, at first we are marking the things as visited. Okay, and then if it is not visited, we are visiting it just like the normal DFS, and then we are assigning the character to TP just like I told you. And if you assign 122 to a character, then it would be assigned as Z. So now it is at Z and we are pushing it to the string. Okay, now we are doing this, and this is doing the topological, this would give us the topological ordering in reverse order. Okay, so now we are doing the same thing. We have given the characters, so we are visiting every characters. If that is not visited, we are visiting it, and now we would have a reverse ordering of topological sort. So we are reversing it and then we are returning it. Okay, now we are wasting some space here. Okay, it is negligible, but we are wasting it. Okay, so how to combat that? You can make an array of less than 30, and what you can do is you can simply use the ASCII values but subtract the value of a. Okay, I tried to keep this beginner friendly, so I didn't do that. But if you are in the intermediate level and if you are going to give the interviews in recent times, then you can consider keeping this as a point. Okay, so if you give this approach to the interviewer and if you have successfully implemented this, then the interviewer would tell you to do space optimization, and then what you would do is you would simply take an advantage of subtracting the ASCII values of A itself. Good to go. So that is it. Can everyone tell me if there is any doubt or if you have successfully understood the topic? Okay. So I would be waiting for 2 minutes. I would be waiting for not 2 minutes, 1 or 1.5 minutes. After that, I would be turning this session off. If you have any queries, please tell me. Okay. Thank you so much, Ankita. Thank you so much, Swagger. Okay. So I waited for around 1 minute 30 second, and I didn't get any doubts. So I assume that you have successfully understood this question. But if you have not understood a single part, and if you are facing some issues, or if you want me to explain anything again, or if you have a different problem, then what you can do is you can ask me on LinkedIn and I would be helping you. Okay. So that's all for today. Thank you. Have a nice day. So this is me, Siddharth Hazra, signing off.